A very good morning, everyone. So let's start the session. I'll introduce myself again. So I'm Vishwaja. I'm working as a senior data scientist in an MNC. It's been more than 5 years since I'm working in data science, and I've been working as a data science tutor for more than 2 years. So today's from the yesterday's workshop, like we are having like understanding the journey of data science. So yesterday I've covered a few topics and today we are going to learn machine learning and deep learning. So I'll give you a recap of what we discussed yesterday also. If you have any doubts also, like you can text in the chat box and you can unmute and you can also ask me after the completion of topic. We also have like Q&A session. So like if you have any doubts or if you want me to explain any particular topic again also, that is fine. Like I can do that. So just uh, you can text in the chat box. I'm sharing my screen. If I'm having any audio issues also, please let me know. I'll check and I'll correct it. Let's have a recap of what we discussed yesterday. So as we are discussing about the journey of data science, so data science is a rapidly growing field and you have a lot of data generated day to day, and you are the demand for the data and demand for the data science is huge nowadays. And like if you are being like if you want to be an aspiring data scientist or like data analyst or data engineer, so it's very important to understand all the skills, like you need to have all the skills in the data science, that may be in coding or in terms of like mathematics or like machine learning algorithms and deep learning. Like if you want the next level, if you want dashboards, you have to understand the data visualization. So yesterday we discussed like what are like roadmap Python programming language and its fundamentals, like what you have in Python and what are the topics you need to understand, and probability and statistics. Like you can see in this picture, you have like mathematical concepts as well as like probability and statistic concepts, like which are really important for the data science. And you also have something like data wrangling and data manipulation techniques by using, like you can use either SQL as well as in pandas. And pandas is nothing but which we use in Python library. So we have a pandas, NumPy, Matplotlib, and Seaborn, which we use in the Jupyter, which I've showed you yesterday. And today we are going with the machine learning concepts and like what is machine learning, what is deep learning, and what are the algorithms you have in machine learning. And then I can also help walk you through the deep learning techniques, like what is text summarization, like how we are using NLP nowadays, and like for the deploying tools, like what we can, like which apps are used, like whether it is like Streamlit or Flask or Docker or Kubernetes, like how we can deploy. And then like how we are completing the whole journey of a project, let's say from the designing, from the developing, from the deploying perspective. Like we can understand the whole project of any particular product or any app. So as I said, yesterday we saw like what is Python and what is SQL, like which are the basic concepts which we use, as well as in terms of Excel and Power BI. So today we are going to understand like what is machine learning and how we are having the machine learning. So as you saw, like if you see a life cycle of any project, like machine learning is like a like it is an important area where you need to understand the basics of machine learning clearly. Then only like you can understand what algorithms you can use and like how we can go to the next step of deep learning and so on. So, what is machine learning? Machine learning is like most popular technique nowadays, which are used to predict the future by using the whichever the past data we have. So, let's say, so in this also like we have something like uh, supervised learning. Like further, if you go, you have something like supervised learning, unsupervised learning, reinforcement learning. Second, I'll show you the picture. So here it is. So AI is nothing but which is a combination of ML and DL. The whole becomes an artificial intelligence. So artificial intelligence is nothing but it is a combination. It has both machine learning as well as deep learning. So if you are familiar with machine learning and some parts of deep learning, that will really help you in upcoming projects or like in your day-to-day activities in your job also. So let's go to machine learning. So what are the types you actually have in ML? So in ML, you have something like supervised learning, unsupervised learning, and reinforcement learning. In supervised, so it is again further classified into regression and classification. So in the regression also, like let's say if you have something like numerical variables, continuous variables, how we are dealing with the data. If you have something like categorical variables, how we are dealing with the data. So all those things we can see under the supervised learning. So let's say what is unsupervised learning. So unsupervised is nothing but like if you are not knowing what is input and output, and if the data is not labeled, that will become an unsupervised learning that we can discuss in the next detail, like step by step. So again, reinforcement is like combination of unsupervised and supervised. And here you have different techniques. Let's say in the real time data, like if you want to understand, if you want to forecast the market, if you want to forecast the sales, like which type of model you are using. You are using regression. Let's say you want to detect in the day to day mails, like whether it is spam or not spam, whether you want to do in an image classification, if you want to see whether it is fraudulent or not. So all these things which are classifying something, you can understand by using the classification model of supervised learning. So same as in the unsupervised learning. So in the real time data, you have a big data which is coming up, which may not be always a labeled data. So there what happens, clustering comes into picture, clustering or dimensionality reduction. So in the clustering, you also have something like recommendation systems and like KNNs and different things. So let's go and deep dive into types. So here I'm saying like supervised learning is nothing but here you have some label data. If you see this picture, you have something like label data. So you are saying you are passing the data and you are also passing some labels. So what happens when the model has trained and when you are predicting? So it gives you in terms of particular labels, let's say carrots, which the carrot label name, or like you have tomatoes name, whether you know the input and you are expecting the output clearly. So the input and output will be in a particular format. So if you understand this, the you have machine learning, machine is trained with the well labeled data and you are giving the inputs and outputs which are matching. So that becomes a supervised learning. In that you also have subcategories, like if the output, like whichever the output you are getting, if you have numerical or continuous numbers are same thing. Sorry. So if you're having something like continuous numbers, let's say from 1 to 100 or like 0.01, or like you're having some continuous random numbers, then that becomes your regression model. So your regression is nothing but the output is in terms of numerical numbers, whereas classification is nothing but you are trying to classify something. Classify is like, let's say you have this data, like you want whether it is yes or no. or whether you want something in terms of spam or not spam. Just you're classifying yes or no. So if the output is something you're classifying and you're dividing into some segments, that again becomes into a classification model. And in further classification and regression, we have different models which are used. So let's say in terms of regression, just now I told you, like if I want to understand what is my temperature tomorrow, like what will be the temperature and today's temperature, then temperature is in terms of number, numerical number. So I can't just say whether you have something rainy or hot. Just I can say in terms of like it is like 50 degrees centigrade or it is 40 degrees because it is summer. So you're using that numerical number category, you're saying continuous numbers. So that's why it comes into regression. Whereas again, the classification, like what will be the temperature, whether it is hot or cold. In the beginning itself, you're classifying whether it is hot or cold. I'm not saying any numbers. I just want whether it is hot or cold. So that is like you're classifying. So that becomes a classification model, and this is a regression model. So if you see here in the supervised learning, in the regression also you have different models. In the classification also, again further you have different models like algorithms which we are talking about. So you have something like decision tree, random forest, and you have linear regression. In the linear also you have polynomial regression, multilinear regressions, and all these terms you have the continuous output. That's why all these models will comes under the supervised regression. Whereas in classification you have knn, and again decision trees also you have like, well, depending upon the problem statement, you have decision trees, random forest also in the classification. And you have logistic regression. Logistic and linear are like the basic regression models. Logistic regression also comes under classification, although the name says it's regression, but here you have a difference between the logistic regression and linear regression. I'll try to explain like what is the main key difference, why we are calling logistic regression as a classification also. So these are the few models which comes under the classification model under supervised. So now let's also understand like what is unsupervised learning and what is the difference between here unsupervised and supervised. So now, what is unsupervised? So as I told, we don't have any labels. You have unlabeled data. So the real-time data, which we are getting also mostly unlabeled data. We don't have pre-labels like this is this category or this name is this. So you have the raw data, which is unlabeled, and you are trying to interpret. So you're giving your algorithm and you're doing all the training and test process. Then what happens? Then it will gives you the output. The output which is comes under also, it will not classify according to, see here also you are saying just classify whether it is red capsicum or green capsicum, I don't know, just I'm classifying under the, it is something like capsicum segment, this is brinjal and this is like onion. So that's where the classification comes. Here you don't have any particular labels. Let's say if you have some labels, you can label like red, green, then it becomes again the, it will comes under this. But here we are just classifying, we are not seeing the color or we are not having any labels. So again in this also you have something like clustering. So what are the different segments? And unsupervised learning is nothing but the models you can use as clustering. And you also having something like association, like this is also in the next level. Like if you have the huge data and you are trying to classify something, like, or you want to divide, so you are using, this is the big level data which we have some uh, mostly we are using the supervised unsupervised clustering level as of now. Like if you have the large chunk of data, then this will be your high level data where you are trying to categorize something. So let's say most of the data what we get is like continuous data. Continuous, that may be in terms of supervised or unsupervised. but the most in terms of healthcare or marketing segments or in terms of finance domain. In any domain, you are mostly having this continuous variables and supervised, unsupervised. So here I'm saying you have something like KNN or K means clustering as well as PCA. So, and you have different techniques to divide into clusters, particular clusters. So again, like we can dig deeper and then we can understand like what is clustering and like what is unsupervised doing. And then you also have something like reinforcement learning. In that, it is a combination. So I'm saying semi-supervised or reinforcement learning. It is nothing but you have the combination of both labeled as well as unlabeled data. So here what we are doing is like it's like a mixed kind of thing where you are having the large amount of unlabeled data and small amount of labeled data. So you already have names, but the names are not complete. So you have both mixed of labeled and unlabeled data, and you're trying to give the learning you're giving to the machine learning model. And now it is going to the proper data set, and then it will try to give you the output. So this comes under the semi supervised learning. Second, okay, I'll tell you what is the difference between the continuous and categorical variable. For this, just let me show you in terms of, let's take an example. So now here I'm saying random 100 or 10. So if you see any number, any numerical numbers, if you try to see, let's say you have something like 1 and 100. Like in between 1 and 100, you can also divide those into like I can have 10, 20, 30, 40, 50, 90. So in between, I have something like 1 to 90 numbers I have. So if I still want to divide in particular, like 1 to 50, so still I can have like 1, 20, 30, 40, 50, 60. Sorry, 50. So I have 40. Then if I want to further divide into 10. So in between 1 to 10 also there are continuous numbers. So continuous like you have 1, 2, 3, 4, 5, 6, 7, 8. All these numbers you have. Still I want to divide between 0, like 0 to 1. Here also I have still continuous numbers like 0.1, 0.2, 0.3, 0.4, 0.5 till 0.9. So if I want still further 0 to 0.1 also I have 0.01, 0.02. So when you are taking in terms of numerical numbers, numerical or continuous is like same thing. Like you have the continuity of the variables. Like if I take a particular range 0 to 100 or like 1 to 100 or 1 to 50, you have the continuous numbers. Whereas like if you have like you're getting emails, day-to-day emails, you want to separate something. This is like garbage one, spam one. This is like not spam. Not spam is like I can use. Spam is nothing but I don't want to use. That is waste of my time if I open my mail also. So you are categorizing something. You are dividing something into particular category. Spam, not spam. Yes, no. Let's say if I want to say any person is like pass or fail. I'm just using it pass or fail as a category which I can divide based on like if it is like a number or numerical, then that variable or that data becomes a continuous. Category is nothing but you're dividing some segments like 0, 1 numbers or anything categorical wise. So category is nothing but which have the segments. Here, any doubts? And okay. So that's where, like, when you're using any output, like if the output is in this format, then you can say, okay, it is regression. If you want output in this format, like I don't, just now we saw the temperature. What is the temperature? I want in terms of numerical, I want 40 degrees, I want 50 degrees. Then this will become your regression models. And the output, if you want something like summer, winter, or like rainy or cold or hot or cold, then that becomes like a classifying. You're something classifying into the whole data. So that becomes like a classification model. So I hope like you're clear with supervised, unsupervised, and semi-supervised. So depending upon the labels, which is labeled, which is not labeled, which has a few labels and not labels, that becomes a semi-supervised learning. In the semi-supervised learning also, you have a few models. Like you can also expect something like, uh, if it is like a random data, then you have to do some mixture models, like mixing models, and you have something like semi-supervised svm. You It is also used in supervised and semi-supervised. So now let's also understand the machine learning flow, like how the process is happening and how we can learn, like you can understand step by step. So as discussed yesterday, I said like SQL is used to retrieve the data, or like to collect the data from the data lake or the different data sources or different databases. So we have something like, our first step is to retrieve the data from the data lake. For that you can use like Snowflake, or like you can use SQL, MySQL. In the MySQL you can use SQL queries, or you have different queries which you can pull the data. After pulling, what you are doing, so the next step would be like a data cleaning. So yesterday we discussed like what is data cleaning and how we are exploring EDA is nothing but exploratory data analysis, how we are getting those EDAs. So in the EDA, in the cleaning of the data also, like you have something like uh, missing values. Like in the cleaning, first you need to see whether you have the data is correct or not. So the next step would be like whether you have any missing values or not. Let's say you have 1,000 labels, like 1,000 rows. In that 1,000, whether any column is missing. So if I have missing values, then I can delete the whole column or whole row in the first step. If it is not important, again, if it is important, still I have the missing values. How we are dealing with those missing values? So how we are finding the outliers and how we are trying to manipulate the data, and how we are going to the next step. Everything comes under like data cleaning and data pre-processing basically. So from there, you also do the EDA. EDA is nothing but the visualization which you see. So yesterday, as I told you, like you can do different plots where you can understand how the data is varying, how the trends are varying. So here you can also see, you can use correlation plots, you can get the outliers by box plots, bar graphs. So you will understand how the data is varying in a visually. So that's where EDA comes into picture. After EDA, what you're doing, you will get the data. So how we are preparing the data, preparing and transformation. This one I can walk you through an example also. So we have different feature scaling techniques. From there, how you are developing and training the model. From there, how you are validating and then deploying. So this will be like a whole journey of a particular development phase. So you collected the data, you cleaned the data, you are also analyzing the data, then you are giving further preparation. Like you are saying, okay, uh, let's say you are measuring, you have something like grades, ratings 1 to 10, and you also have the other variable price, 1,000, 2,000, 10,000. Other variables you have 10, 20, 30. So all these three variables are like different ways. So Here, let's say you have a date, a name. You also have, let's say, rating or like random, and you have price. So name is nothing but I'm saying like Vishwajam is a particular name and some rating is 4, and like I've purchased, like I gave the rating of a particular product, let's say ice cream, and the price of my ice cream would be like 90. And next I bought some chocolate, and this rating I gave it is very bad. I gave this much rating. I bought it with 50 rupees. So like that, if I have the data, like I'm saying this is like a random number, like this, sorry, this is like a high number and this is like a low number. Now if I'm trying to compare the whole data, so I can't just compare 90 with 4. Like I can't say this 90 is high, that's why this is the more impacting. No, I can't just directly can't go with the numbers. So what I'll do, I'll try to get everything into a normalized format, standardized format. Let's say by using the statistical methods, we can do, like we have something like normalization and standardization, which will make whole data into a standard format. Let's say I can't compare this 90 with 4, or I can't compare directly ice cream with 4. So this is a different segment. This is all these things are different. When you're directly passing through a model, like if I pass through this model, what happens? Obviously model will detect that this is high value, so it will give you like high weighted value. Obviously it will give you like this is high, this is low. So that's where the standardization comes into picture. So preparing the data is the most important thing. You can't just pass directly the values. For few models, if you directly pass, it will work, but most of the models, if you are doing something like a regression, mostly preparation and transforming the feature scaling is the most important step after data cleaning. Then only you can directly pass through the model. Then the validations and confusion matrix and all this comes into picture. So this is the cycle. We can go deeper, like we can understand like how the next steps has, like in between, like if you have any doubts also, like we can take. Okay, so that means like I can continue the further topics. So, as I said, the data collection. First thing is like collecting the data or retrieving the data. So, let's say if you already have a particular data source where you can extract. So, let's say most of the companies like Amazon or like you have a big giants where you can already have the data. Just from the data, like you can try to collect from the Snowflake or like Azure Redshift, like AWS. So, you have different platforms where you can collect the data, collect, and then the next thing is like again you can explore, like you can retrieve from the data lake. We are using different queries and you are taking, and then you're trying to explore the data, whether it is like a univariant variable or whether like you are trying to understand bivariant analysis, data cleaning and feature engineering process comes under data exploration. So this is a process where you understand the data in detail. So after getting the data, you should understand like how it is helpful for me for my problem statement and how can I go to the next steps. So there, I said, as I said, like data cleaning is a process where you're preparing the data. So first step is like you have to remove the duplicates value, because you have lot of duplicate values. If you directly pass the duplicate values or if you pass directly random numbers, the model also can't identify the data, can't identify the patterns, and then it will give you some random output. So that output will also, you'll have the high accuracy, you will have some random number overfittings, and so many things can happen. So that's why data cleaning, in the data cleaning, removing, first you should check like whether you have the duplicates or not. Then you should also look for outliers. And the outliers is nothing but, let's say, if you take this data, so here I have 8 data points. Out of 8 data points, I can say like this three are in, like it is moving in one direction. Like you have like a continuous, if I take the average, or if I take some of these values also, everything is in a one pattern. Like if you see 100, that is like an extreme pattern. That means like this will be like a outlier. Like if I want to take an average of this one, how much I'm getting, like 4.4. So up till here it is okay. Like if I take something with 100, how my average is varying, 16.3. So that means like there is a lot of variations if you have a outlier. So that's why it is better to identify the outlier, and you have to check what are the things you can improve the outliers, or like you can also remove the outliers. According to the data, you have to check. It's not like just to see and randomly delete the outliers. You have different techniques where you can identify as well as you can remove those outliers. So that's why first thing is like you have to see the duplicates and outliers. Then you can also see with the missing values. Just now I told you, like you, if you have some important column missing, or like you have the column name but the rows are missing, like you have no values in that. So you can try to fill those values, or you can also remove values, or like you can have different methods like mean, median, imputations, where you can fill those. So that will comes under, like we can go through those things in detail, like when you join the course vita, like we can have like discussions of how we can deal the machine learning, how we are cleaning the process, like what are the outliers and all these things, like we can start. As of now, I'm just giving a glimpse of like what are the things we have in data cleaning. So again, removing the outliers and extra spaces. So here you have the checklist where you have to see missing values, outliers, and duplicates. And you, main important thing is like date also. Like let's say today you have one particular format. Let's understand. Uh, I'm writing 20 date, 10th month, and 2024. So my date format is in this particular way till today. I got the new data, and I dumped the data, like I'm just adding those data. So what happened? That is in terms of, this is month, date, and I'm having this one. So if I directly add this and this, obviously you're getting a wrong value, because here you are saying this is my DDMMYY. First is my date, 20th date and 10th month. But when the new data is in this particular format, which is like 6th month, 28. So obviously if you directly randomly impute those, and if you are not checking the dates, so ultimately you are doing a wrong step. So that's where the date also, like you have to check the date when you're dealing with this data. So data cleaning will take in real time data. Let's say you are assigned with a project of 100 days. So mostly 80 days or 70 days, you will be working on data cleaning only, like data cleaning and data pre-processing, EDA. All these steps will, you are doing the 80% of time. Modeling and like, algorithms you are applying and coding, all this comes into the next step. So that is just 20%. Mostly if the data is clean and good, then the model obviously gives you a good result. If you directly pass random values, then the output will also vary. Okay, I'll explain the flow chart. So here we are discussing like this is also similar to what we discussed in the yesterday session. So here the first thing is like okay. So for collection of data, so let's say the first step would be like you have to collect the data. Collect, or like you have to retrieve the data from different databases also. Like you can collect, let's say if you are having something like surveys, or if you are having some you're taking direct reviews, or you are doing, then you can use web scraping, and like you can use some queries to get the data. So that will be your first step. Ultimately you are trying to get the data you are collecting. After collection, what will be your next step? Your next step will be like you're cleaning the data, and then you're doing the analysis in the data. So the next step is like the data pre-processing. Pre-processing is like cleaning and analysis. Then you're trying to prepare the data. Analysis of original data. Then if you're trying to pass in, like if you're trying to pass those data with the model, like train the model, then you have to prepare the data. So preparation and transforming the variables, that will be in this step. And after that you are trying and developing the model. So the development phase comes here. And after the development, you are like you will get the result. You're giving the model, the results you will get here, like what will be the accuracy, what is the next steps. So you have to check accuracy, whether it is high or low, whether it is matching with your what you are expected. And then after validation, you will try to deploy into the production. So for the deploying also, you have different tools where you can deploy. Like this whole process is one thing, and then you are trying to deploy into the production, and then you will try to monitor, like if you get the updated data, whether it is flowing continuously or not. So whether you're having rapid changes, then that comes under like the DevOps or like ML ops. So that is like machine learning operations. So this is a flow. And in that, I'm trying to explain how we are collecting the data, how we are exploring the data, and like what steps you should see when you're cleaning the data. So these are the steps. And here I'm also saying like what is EDA? EDA is nothing but exploratory data analysis, where if you have a data set, like how you are exploring the data, like how you are seeing the trends, how you are going with the patterns, how the pattern is going. That's where all this chats comes into picture. In this chat also you can see you have box plots, histograms, you have, so these are the different kinds of charts where which are helpful for us to understand the visually understand the data patterns. So after EDA is done, like just now we discussed like how the outliers are impacting, how we are having the missing value effects. Like if I have a random missing value, how it is affecting the data. The steps again we can like you should do it in a data pre-processing step. Next thing is like a feature engineering. So feature engineering or like model evaluate, like model building techniques. So in this technique you are trying to select which are important relevant features, and you are trying to create a data. Let's say you have a different source of data. From there you're collecting the raw data, you're cleaning, and then you are selecting the features. Let's say if I'm taking a house prediction data, what are the important features I actually needed? Let me show the data. So this is the data which I have for the house prediction. So let's say I want to predict the house price for the next years based upon all the information given. Let's say this is the house name and house details. This is the house ID. And you also have the details of host, whether they are verified or not, like whoever the selling, verified or not, and host name and host details, what are the neighbors, how you have neighborhood, and you have the address of that particular house, and you have all the details like whether it is located in this particular country, this area, country code, and your room types, whether you have two bedrooms or three bedrooms, whether it is like private or like entire home, construction year, price, and these are the whole data what you got, like your house rules. So in this data, first thing what I'll do, just now I told you, like I'll try to see the duplicates, I'll try to clean the data, and I'll figure like whether you have missing values. First thing is like you also should understand which is your important feature. Feature is nothing but, let's say, what is my problem statement? I should predict the price of upcoming years based upon the whole data. First thing, what is the my target or main important is like price. So this is my important feature, price. First thing, construction year also comes into picture. Let's say price can be varying due to the construction. Let's say if it is an old building, what you can say, okay, this price is low. If it is like latest building, the price you can keep it as a high. So my construction year is also important. And I can also see the reviews. Like reviews also important for me. I will check my reviews and then I'll buy, like whether it is good or not. And also like this is like some part of things are useful and some part is not useful for me. Like if it is useful, I'll take to my model. Like house rules also important, and room type is also important for me, and how many rooms also important for me, location is also important for me. These are the important features according to my problem statement. So I want verified or not, because I want for the next analysis, like for verification, like verified host, how the price is varying or not. And your basic name is like a primary thing, name and ID, you will have the primary. So here what I'm doing is like I'm trying to collect the important features from the, let's say in the real time data. Here you at least have 25 columns. So but in real time you will have lot of columns, lot of rows, but you should understand like what your key features which are helpful for your problem statement. So out of 25 I am taking like 10 features which are important for me, and those steps also like you can do it in the feature engineering. So now, just now I told you like I have taken all these features. Now you can see this is year, this is price, and this is like rating. The numbers are again different. I can't directly dump my model like compare price versus year versus reviews. That will give you obviously a wrong values. Here, that's what I do a feature engineering. I'll take like normalization and standardization. This is the actual data, random data. After normalization, you will have like a like continuous group of data. After standardization also, you will have like a standard format of data. How we are doing the standardization, normalization, that will be again your deeper things like we can understand if you once you take this course, because this is an important step here. Then you can train the data, train and test split. Let's say you have 100% of data. Training and testing is nothing but you will try to split the data into 80% of data, like whether it may be 80 or 40, 80 20 or 60 40. You're dividing x and y variable. X will be like your training set, you're training this, and you're testing the y variables. From this, you are trying to train and test, you are dividing 80-20. So the ratio of data, let's say you have 100 points, 80 points will go to the training data and 20% you will go to the test data. From this, how we are going through, like how we are deploy, like how the model is trained and how we are predicting, that comes into the next process. Like let's say in the machine learning, you have different algorithms. So according to the data, according to the problem statement, if you want a regression, like let's say if the output, like just now what we discussed here, I want to predict the price. So price is nothing but it's a numerical number. I want to get something in numerical number only. So that means completely I'm saying that it's a regression model. So if it is like regression model, I'll use my regression model things like linear regression or like decision tree, random forest. I'll use all those algorithms and then I'll pass to my model. There it will give me my accuracy, my precision, my recall, and what according to this metrics, then I can go further. So I can walk you through an example also. I'm taking a available data so that like you can also refer house prediction data if I want to get like linear regression. So here you can see clearly. So first, what is my problem statement, what I'm aiming to get, and how I'm preparing the data. Let's say you have taken the housing data. I have all these details which we have, and how I'm doing the data cleaning, like removing the null values and imputing data imputations and exploratory data analysis, where I told like I'll see like how my data is varying, like which is high or which is low, and I can identify the patterns. So I can identify the correlations by this, and then I can go to the next steps. So here I'll try to train the model. So after training the model, I'll pass and a feature engineering step. From this, again, I'll give the model like according to the regression or classification. I'll say, okay, I need linear regression model. I'll pass like I want something like linear regression. I want something like decision tree. I want to pass through the random forest so that I'll pass a different models. Then I'll get some scores. Let's say if I'm getting the linear regression, you will have root mean square error, different error values. You will have the accuracy. So after getting the accuracy, like how you can see, let me show you. Yeah, multilinear regression also works. Okay, I can show you a different one. So here, after all the data pre-processing and then model building, here you can impute random forest or like linear regressions, or if it is classification, then you will get the accuracy. Let's say this is 90% accuracy. So by accuracy only, you will try to understand like how my model is working. So these are like a model metrics which are helpful. So model evaluation is nothing but by using the techniques such as training and testing, cross validations, you will get few metrics which are really helpful to analyze the your output. Let's say according to the accuracy only, you can say whether your model is predicted correct or not. So if your accuracy is like more than 90% or more than 80% in real time data, then the model is performing good. If the accuracy is like less 40%, 50%, then you are saying like there is something wrong with the data, or like the process which you have done is wrong, or like you have to re-verify the root cause, and then you have to get a good accuracy. So based on this only we can say whether the your model is performing good or not. So it is not only about you have accuracy, precision, recall, and F1 scores. So this will become your ultimate output, which helps you to understand like whether your model is performing good or not. So this is about the machine learning concepts, and let me also walk you through deep learning. So in this workshop, I just gave you like glimpse of like how we are performing the machine learning models, and let's also see the deep learning. So as you said, as we know, like it is a subset of AI, where you are having like if you want to understand further more deeper, like if you want to get more insights than machine learning, you will use a branch of machine learning called as deep learning, where it is almost similar, like few things which are similar to human brain nervous system. That is like you're calling as like you have ANN, CNNs in the deep learning. Deep learning is the most powerful technique for any data scientist, or like if you want to explore the data in deeper, you have to understand the complex networks which are connected. Uh, Here you have different types of deep learning, which are like artificial neural networks, and you have something like CNN, convolution neural networks, RNN, and all these encoders, decoders, and backward propagation, frontward propagation, all this comes under your deep learning techniques. And nowadays, like auto encoder is nothing but like your chat GPTs. And like if you want to get the text summarization, we are using encoders day to day. Like now the GPTs and OpenAI is like booming. So if you have a deep, like if you have a good understanding of deep learning, that will really helps you. And you also have something like NLP techniques also. In NLP, I'll show you how we can use this NLP. So NLP is nothing but the natural language process, where see here I'm saying like here I just have a numerical data. So I have a tabular, like I have some tables, I have rows, columns, numbers, so that I can get my output. Let's say if I'm having a text data, if I have some random normal text, I want to understand like what will my accuracy, or what is my output. Then what can I do? If I just get a text data, how can I deal with that? So that's where natural language process comes into picture. So if you want to understand the sentiment analysis, or like let's say if you want to take a review of a company, in Amazon, I've purchased this particular product. I want to understand whether it is good or bad. What you'll see, you will see the reviews. Reviews are written in terms of text. So if I want to further classify and further analysis, I use NLP sentiment analysis. This helps. This will convert the whole text into the machine understandable language, and that then you will do the same process. Let's say here you have data, you did data pre-processing. Here you will have text, you will do text pre-processing. So in the text pre-processing, how we are dealing with the data, let's see. I'll show you the data set. So here, this is a data set. This is like a normal review data. So it is saying me, so I can also show you here. If I get something like this, house rules, or my what is the review of that particular thing, I can not directly dump this data into my data set. So here I will use NLP techniques. So this is my data. For this, you have data pre-processing. So first thing is like you should clean the data. How we are cleaning the data, how we are using different cleaning techniques, how we are tokenizing the data, like tokenizers, stemming, lemmatizing, how we are dividing the data, how we are getting the word clouds, all these things. Like we can go deeper understandings when you understand like NLP, what is NLP, and how it is actually useful in real time data. Let's say um, we are in a healthcare sector. In the healthcare sector, what data you will get in day to day? Your doctor prescriptions or like any procedure description of any particular disease. Let's say I had fever. I'll go to doctor. He'll prescribe me something. So I have fever or like any disease description only. I have the text format. Other things also. Everything is in text. So like nowadays you are having more number of text also, converting those text, and we also have OCRs. OCR is nothing but if I have like authorized computer picture, like any picture, I want to take the data, then OCR comes into picture. Like in the finance domain, so if I want to extract the data, how I'm using in finance domain is like OCR techniques, NLP text techniques, and summarization techniques. In the healthcare also it is rapidly using. So the straight data you can't get every time, so you have to find the other ways, like how you are doing the pre-processing and how you're getting accuracy. So the next level, like if I go further, I also have something like text summarization, which is now rapidly booming. So I'll just give you a glimpse of text summarizations, encoders, decoders, and BERT. So here, text summarization is nothing but, let's say, um, you went to a hospital. Doctor gave you like 3 4 PDF documents, like he described your disease, what kind of lab reports you want, what kind of medicines you have to take. So that's where you have a long PDF. And like if you want to read that PDF, like it is difficult for every patient like to understand this. So if I want, so then what I can do, I can simplify those 1,000 10,000 words into like 100 words or 20 words, which is understandable for a patient. So that's where LLMs, like large language models, comes into picture. So this is also like further in the deep learning you will go, you can get LLMs and NLPs. So everything is in terms of text. So I'm not talking about the tabular data, I'm just talking about the text data. So if I get all these things, then how can I build? So you have something like BERT. You also have something like OpenAI keys. So OpenAI, let's say if you are doing in a chat GPT, you can just type the text and you'll get the output. Let's also see the summarization. I'm randomly taking this summarized. So I have this much data. Let's say if you see, I have so many, some 3 4 paragraphs of data. So I'm trying to copy all the data just till here, copy, and I want summarized format. Then what I'll do, let me get this. Now I pasted which are the words you have. So now if I say summarize, what it is doing, the Virat Kohli's I have pasted almost, so this will be like 600 words. Like I've pasted almost like some thousands of words, like let's say 17,000, 10,000 of words, and I'll say I need only particular summarize. For me, I don't want to read 3 4 of PDFs. I want just a summarization with 100 words or 40 words or 60 words. That's where text summarization comes into picture. So this will be like a UI format of the text summarization. In the backend, what you have to do, you should understand like what is summarization. In that you have different types of how you can classify those, how we are giving input, how we are giving the text summarization, how we are using the Streamlit app. Streamlit app is nothing but, let's say you did all the process, and you should showcase, like it should be a easy and user friendly to get me. So that's where I can use the Streamlit app. Streamlit app is also like this will be like same format. You can get the same UI. So just randomly, I can't show in terms of my code, or like if I run my code, I'll get this output. No, like I have to showcase in a proper way. So that's where Streamlit we can use. And after Streamlit, like you can deploy in a different methods. Like you can use lag chains, llamas, and large language models. So let's say this is the, here they have copied the whole thing. And after this, they'll try to summarize. Like you can also give me, like I want something 300 words only. It will summarize to 300 words, and then it will calculate and it will give you the whichever the output you require. So this is like a next step. Like, so I can also teach you this topics in the further, like if you take this course. So in the workshop, I'm just giving you a glimpse of like what are the topics we all have. If you have any doubts also, like you can post it. So today, like we covered most of the machine learning, deep learning, and like the llamas and language models, what we have. Any doubts, like you can ask me now. So this is about machine learning and deep learning. So after this, what you can do? What will be your last step? Last step will be again your deployment. Let's say now you understood the data, you got the data, you cleaned the data, you gave it to no model, modeling is done, and you got the results accuracy. You got again in the further deep learning also you got summarization, and then you also got whatever the required things are done. The next step would be like just now I told you, I can't just show my code and run, and I can't show to the client. I should show visually a good dashboards, or like I should, it should be like a like understandable thing. So that's where you can use like a visualization tools, or you're deploying the whole app by using like we have like open source platforms also. We can build easy interface and then we can deploy. So for the deploying, how you can deploy also, like we can understand in deeper. So that's where the whole journey of a product is done. Then the monitoring is only the thing, like what you can do. If you want me to explain any topics also, like you can say, like we can go through those topics only. So from yesterday to today, we covered most of the roadmap of data science. You can unmute and you can ask, or like if you have, you can uh, drop in your messages in chat box. Or if you want any topics to be repeated, or like if you want me to uh, go understand and the anything also, like just post me, like I'll go through that topic only. And like if you have like you can register your attendance and you can get your certification, just go through this link and just fill all the details. You can also share your thoughts and where we can improve. Ma'am, can you provide the note?
Hello, ma'am.
Ma'am, the link is not open.
Okay. Abhishek and Trinath, can you please check the link is not opening?
Ma'am, you need to give access permission to access the link, ma'am.
Sorry.
You need to give permission
Okay,
to
okay.
access
So
the admin link, ma'am.
got it, got it. I think other link is shared. Just check that.
Yeah, hello.
Yeah, Anupurna,
Yeah,
you
hi,
can.
Sujaya. So,